So today we're going to do something really cool. We're taking a handful of simple electronic parts, a little bit of code, and we're turning them into a legit playable retro game that you control with your phone. And get this, no app, no downloads, just your web browser. Let's dive in. I mean, think about it for a second. We use our phones all the time to tap and swipe our way through the digital world. But what if you could use that same device to control actual physical things? To bridge that gap between a tap on your screen and an action happening right in front of you? Well, that's the whole idea behind the Internet of Things, and we're about to build a piece of it right now.
To get our hands dirty with this idea, we're going to build a game called Obstacle Run. It's the perfect first step, really, because it's fun, it's totally interactive, and it shows you exactly how we can make the physical world listen to our digital commands.
So what are we actually building here? Well, I want you to picture a tiny little stick man running along on a small LCD screen, and he's got to dodge obstacles. Now imagine you're the one in control, making him jump with perfect timing, all from a simple web page loaded on your phone. That's our goal, a totally self-contained wireless retro game.
All right, let's meet the hardware. To bring this game to life, we need a small team of electronic components. You can think of them as the cast of characters, and each one has a super specific, really important role to play. First up is the ESP32 board. This thing is the brain of the whole operation. It's running all the game logic and handling all the wireless stuff. Then we have the 16:2 LCD display. That's our stage, right? It's where all the action unfolds. The buzzer is our sound effects department, giving us that classic crunchy sound when you crash. And of course, your smartphone is the wireless controller, the direct link between you and the game. Okay, so we've got our team assembled, but how do they all talk to each other? Let's take a look at the blueprint, the plan for how we connect all these physical parts and then program them so they work together like a well-oiled machine.
And this is where the magic really happens. The secret sauce is Wi-Fi. You see, the ESP32 chip isn't just running the game, it's also acting as its own tiny little web server. It literally creates its own Wi-Fi network that your phone connects to. And that's how your phone's browser can send commands straight to the brain of our game. Pretty clever, right? The whole system really has two sides. On the hardware side, you've got the ESP32 as the brain. The LCD screen connects to it using a really simple two-wire system called I2C. It's just a standard way for these parts to chat. The buzzer? That's just wired to a pin that the ESP32 can turn on or off. Easy. Then, on the software side, the whole game is written in C++ using the Arduino environment. The code tells the ESP32 to fire up that web server, which then waits for your phone to send a simple command, an HTTP request, to make our little guy jump. So let's trace the path of a single action. First, you tap jump on your phone. Instantly, that shoots a signal, an HTTP request, across the Wi-Fi to the ESP32. The ESP32's code catches that command and updates the stickman's position in its memory. Then, the LCD screen immediately redraws itself to show the jump. And finally, if you mess up and collide with an obstacle, the buzzer goes off. And all of this happens in a fraction of a second. It's practically instantaneous.
Now for the really cool part. How do we get from abstract lines of code to an actual character running and jumping on a physical screen? Let's pull back the curtain and take a peek at the C++ that makes it all happen. When you look into the source code, you're going to see a snippet that looks just like this. And at first glance, you might just see a random jumble of numbers and letters. But believe it or not, this is the digital DNA of our main character. This isn't just a block of code. It's a picture. It's a set of instructions for a tiny artist living inside that little chip. And what you're looking at is a concept called a bitmap. Think of it as a blueprint. Each line of binary numbers is one row of pixels. A 1 tells the screen, turn this pixel on, and a 0 says, keep it off. You stack all those rows on top of each other, and boom, you've literally drawn our stickman on the screen. It's art made of ones and zeros.
And the rest of the game is built on logic that's just as simple and elegant. A variable called cactus pause just counts down, and that's what moves the obstacle across the screen. How do we know if you crashed? Well, the code just checks, hey, are the stickman and the cactus in the same spot? Your score goes up every time you clear a cactus. And to keep things interesting, the game gets a little bit faster every 5 points. It's a dynamic, challenging game built from the simplest of rules.
So yeah, it's a fun little game. But why does a project like this actually matter? What's the bigger picture? Let's zoom out for a second. This one project is an absolutely amazing launchpad for learning. While you're building it, you're not just making a game. You're learning C++ for tiny computers, you're getting a hands-on feel for the principles of IoT, and you're figuring out how to host a web server on a device that fits in the palm of your hand. You're learning to talk to hardware and design game logic from the ground up.
And these aren't just academic skills. They have direct, real-world applications. You could take this idea and build interactive tools for education. You could use it to prototype other remote control devices. I mean, this is basically a model for smart home automation, right? Instead of making a character jump, a tap on your phone could turn on a light. This is the foundation for way more complex projects.
And that really gets to the heart of it. The Internet of Things isn't just about automatically ordering milk or turning on your thermostat from the office. It's a powerful tool for creating entertainment, for building interactive ways to learn, and for just making technology more engaging and, well, fun. We started this whole thing with a question, so it only feels right to end with one. This project uses a phone to control a simple game. With these exact same tools and the same principles, what will you control? What physical object out there in your world are you going to connect to the digital? The possibilities, as you can probably guess, are endless.